All right, this is 3.4, proofs with perpendicular lines. The essential question that we're going to be asking and hopefully being able to answer at the end of this is what conjectures can you make about perpendicular lines? So we're going to look for different patterns, different things that we can, conclusions that we can make based off of some examples that we're going to do. And specifically, what we're going to be focusing on is being able to find the distance from a point to a line. We're going to do some constructions, we're going to do some theorems, and we're going to look at some real-world examples, all having to do with perpendicular lines. So, first we're going to start off with finding the distance from a point to a line. All right. Now, all of this here simply states that if you have some kind of line, like this line K, and you pick a point that's up here off of line K, and you wanted the shortest distance from that point to this line, that is going to be a perpendicular line. It has to be at a right 90-degree angle. So if you're kind of looking at it and you're thinking about it, if you're standing at some place in the room and you want to go to the nearest wall to you, the shortest distance is going to be straight to that wall. You're not going to walk at an angle. You're going to walk straight up and down at a 90-degree angle. So something like this example 1. All right, I want to find the distance from A to BD. So here's my line BD, and here's my point A. Now here's what I was talking about. I could walk straight from A and go straight to B, or I could choose to go from A to D. Right? But the shortest, if I were to actually figure out the distance from A to B, A to C, A to D, the shortest one is going to be this one right here that forms this 90-degree angle. So because of this theorem up here, or this definition, I guess you should say, we know that the shortest one, the one that I want, really I want to find the length of AC, which means we have to use the distance formula. All right, so let me rewrite that for you, for those of you that don't remember. All right, that would be the distance formula. So if I'm going to use AC, I'm going to take, let's see, I'm going to do 1 minus -3 squared plus -1 minus 3 squared. All right, that's going to give me the distance from A to C. And so let's simplify this. This is going to be 1 plus 3 squared. And this is going to be -1 minus 3 squared. Don't forget the square root. Simplifying this, that gives me 4 squared plus a -4 squared, which is going to give me 16 plus 16, which gives me the square root of 32. And so this doesn't tell me to simplify this or to round it, I should say. So that means I could leave it as square root of 32. Or if we put this in the calculator and we are asked to round it, the square root of 32 is going to be about 5.66. All right. All right. Next, we have some theorems. This first one's called a linear perpendicular theorem, and basically it says that if you have two lines that intersect, and obviously you get a linear pair, 1 and 2 would be an example of a set of linear angles, or a pair of linear angles, and you know that 1 and 2 are congruent. If that's the case, the only way that's going to happen is if line H and line G are perpendicular. That's the only kind of way that you're going to get two congruent angles out of that linear pair. Okay, and we'll look at an example here and hopefully in a minute. Perpendicular transversal theorem, the next theorem that we're going to talk about, says if you do have actually two parallel lines, H and K, and there's a third line, J, that intersects both of those, if J is perpendicular to H, then that means K is parallel to H. So let me kind of say that again. This is your given. You know H is parallel to K, and you know J is perpendicular to H. Your conclusion then is that J is perpendicular to K. So that means this down here also has to be a right angle. Right. Next theorem, it says lines perpendicular to a transversal. Okay, so in this case, you're given that M is perpendicular to P, so that's why there's that 90-degree angle there, and you're also given that N is perpendicular to P. There's that right angle there. So if both of these lines intersect P at a right angle, that must mean that M is parallel to M. Okay, so it's kind of going backwards from this, from the theorem above it. All right, so that brings us to another definition. We're going to call this the perpendicular bisector. Okay, when you have a perpendicular bisector, you're going to see that in your problems. When you see the words perpendicular bisector, or if you see these two, if you come to these two conclusions, then that means you have a perpendicular bisector. So the first thing that's going to happen is that N has to be perpendicular to segment PQ, and that N passes through the midpoint of PQ. So in your proofs, you're going to use then the definition of perpendicular bisector. Okay, so this would be something that we're going to add to our reasons, I guess, word bank when we're doing proofs. So you could say N is perpendicular to BQ, definition of perpendicular bisector. N passes through the midpoint of M, to the midpoint M of segment PQ. That would be definition of a perpendicular bisector. All right, so that brings us to a proof. I know that H is parallel to K, J is perpendicular to H. We want to prove that J is perpendicular to K. All right, so here's my givens. And we go ahead, and these are marked that H is parallel to K, and we also know that angle 2 is going to be a right angle. So that is what we say. We know that the measure of angle 2 has to equal 90 degrees because that's what it means when two lines are perpendicular. That means I have actually 4 right angles. All right? So because of that, we also know that angle 2 has to be congruent to angle 6 because these are corresponding angles. Right? Because H and K are parallel, that means angle 2 and angle 6 must be congruent. And if they're congruent, they're equal. So that's the definition of congruent angles. And so to be a little more specific, that means that the measure of angle 6 is actually 90 degrees. And we would use the transitive property for that. If I spelled that right, transitive, yes, property. And this one would be of equality. Right? And because, so we have that 2 and 6 are corresponding, and since 2 is 90 degrees, angle 6 has to be 90 degrees. And if we know angle 6 is 90 degrees, that has to mean that line J and line K are perpendicular because that's the definition of perpendicular lines. All right, that brings us to our third example here. We have a map. Photo shows the layout of a neighborhood. Determine which lines, if any, must be parallel in the diagram. And we have to explain our reasoning. So looking at this, this is kind of hard to see, but this up here is line S. This is line T, line U, P, and Q. All right, so looking at the picture, we have to determine what, if anything, is perpendicular. All right, so looking at this, I notice that these two streets right here, P and Q, they intersect line S and 90 degrees. So because of that, both of these are intersecting at a right angle. That must mean that P is parallel to Q. And looking at it from this direction, if I'm looking at line Q, I see that I have two right angles here, formed here. So that means these two lines both intersect line Q, and I have two right angles at both of those intersections. So that means also that S has to be parallel to T. Okay, so those would be our conclusions. P is parallel, line P is parallel to line Q, line S is parallel to line. All right, now we're looking at constructing a perpendicular line. So we've got to start by drawing our line. And we're going to call this line M. And then I'm going to pick a point somewhere on here that's not actually on the line. But I'm going to call this line, or point P. All right, and then what I want to do is I'm going to make, or line up my compass. I'm going to scoot this up a little bit. And I'm going to make an arch from P. And I want it to cross line M twice. Okay, and so these two new points, I'm going to call those point A and point B. All right, and now it's going to be very important that your compass doesn't move. You want to make sure that you're still lined up. All right, and I am. And so without changing the settings, I'm going to go and I'm going to use now A as my center point. Okay, and I'm just going to make an arch there. Okay, and then I'm going to do the same thing, and I'm going to put it on point B. And so now I have a new intersection point right here. And we can, if we want to label that something, we can label that Q. And now if I connect point P and point Q, right, this is a 90-degree angle. Okay, that would be a construction. So I would know that line PQ is perpendicular to line M. All right, next we got, next construction is we're going to construct a perpendicular bisector. So again, we start off with the segment, and we'll call this line segment something original, line segment AB. All right, now what we want to do for this one, when we're constructing a perpendicular bisector, we kind of need to estimate. I want to set my compass so that I'm more than halfway. So that looks greater than halfway. So what I need to do is I'm going to do an arch, relatively big. Doesn't have to be too big, but big enough for what I'm about to do next. So I have my arch. What I'm going to do is I'm going to rotate this now without changing the compass settings. I'm going to go back to B, and I'm going to do the same thing. And I want those two arches to intersect. My pen works. Okay, so I've created this point up here. We'll call that, I don't know, let's call it P. We'll call this one Q. All right, so now if I connect those that way, I know that this is congruent, or excuse me, not congruent. I know that segment PQ is perpendicular to segment AB. And if we name this point, we can call it M. I know M is the midpoint of segment AB. And because it's a perpendicular bisector, I also know that segment AM is congruent to segment BM. Right? So that is how you do a construction of a perpendicular bisector, and these are the conclusions you can make when you have a perpendicular bisector. All right, so what I went ahead and did, if you get the notes outline, I went ahead and put out the steps for each construction so that you have as a reference in case you need to study for tests or if you want to practice doing these different constructions, you have something to go by.